All right, so here is your video for your last couple of terrain tools. We'll be looking at slope and aspect as well as topographic profile. So our slope tools, all of our tools this week are pretty straightforward. Here we're still looking at our Utah DEM. You'll see I've brought in the watersheds we created in the previous video as well. So slope, like all of our tools, not a ton of parameters, just asks for the input raster, asks you to name the output. For slope, you'll choose degrees or percent, but again, I encourage you to pick degrees since percent, you can't have percentages over 100, because a 45-degree angle is 100% slope. So you would go ahead and click OK. I already have it done. So you click OK and it would run, and you'd end up with this output. And you can see you have some areas of 0 slope. You can see areas that have up to a 75-degree slope. So if you think of 45 degrees a right angle, you're getting above that slope there in this bottom red category. You can start to see also where some of the good ski areas would be. Next up, we're using the aspect tool. So just search for that, aspect spatial analyst. And like I've been saying, not a ton of things to check, not a ton of outputs or parameters. You can just go ahead and click OK. And we will click OK and run this tool. But you can see I already have it. And I accidentally ran it again, so we'll see it again. You can start to see our little Technicolor output. Let's just get rid of this for now. We can see if we zoom in on some of these really steep slopes that we saw previously in these areas, we can start to wonder, well, which way is this slope facing? And we can see it's bright red, so facing north. We've got northward slopes in these dark red areas. So north face of the mountain. So that gives us an idea of what the lay of the land looks like. So maybe if you are interested in, maybe not here, but solar panels or agriculture, things like that, you would be interested in knowing which way or which compass direction your slope is facing or your hill is facing. All right, so before we do our topographic profile, let's look up our zonal statistics. I can't spell. There we go, close enough. There are two zonal statistics tools. I like to use the zonal statistics as a table because I like to have the table output that I can easily join to any shapefile or polygon vector data set later. So the first asks you for the input, the data that's going to define the zones. We want to find out the average slope per watershed. Maybe we are trying to find a low slope area for agriculture or building, or maybe we're in Utah and we want to see where we should put our ski slopes. So our input is our watersheds. The ID field, the zone field doesn't necessarily matter here since this is we created this data. We don't have it's like these watersheds are named by their name or a particular number. Your input raster is going to be your slope raster, and we'll rename it as you need to. Here with the statistics type, you can choose which statistics you need. We just want to know the average, but you could look at maximum, minimum, range, whatever you wanted. So we'll just pick that mean and we'll click OK. And guess what? I've already run this as well. But that would run, and you'll see you get a table. We can open the table and see that in, let's see, in this one watershed, there the mean slope is 0.2 degrees, and we have it all the way up to maybe, I always do that wrong, 36 is the average, so some of those really steep ones. Now remember, some of these are going to be funny because they're the little ones at the edge of the grid image, so we're really concerned about these couple big ones, but just for demos. So we can then join our table, validate our join. That is fine. Wait, the following match field. Oh, that's fine. That's okay. So a couple didn't match, but that's all right. again, just for demo's purposes. But then we can go over to our properties. This is why I like to use it as a table. We can go over to our properties. We can change it to not area mean. And we can start to see, I'll just leave it here, where some of these higher, steeper watersheds are. So we can see that this is interesting because this has that big lake in. It really levels out the, or averages out the slope to this 9 to 15 degrees, even though there are some areas that have that 70 degrees, but it's got this just big flat spot right here. So you can see this is one that's pretty steep on average, and then some of these little itty bitty ones kind of got thrown in there. So this would be interesting to kind of think about, is this really a useful analysis if we have that big flat spot, or if we can take it out and just average out these areas later. We also can create our topographic profiles, which you don't necessarily need the polygons, but we do the areas, we use it in the lab, so that's why I pulled it up. So we're going to pull up, for this, we're going to pull up a particular toolbar. We're pulling up, we're going under Customize, Toolbars, 3D Analyst, and we can start to draw the topographic profile, which is, first we have to interpolate the line. So we'll go to this one, we can turn these off for now. And we can start by figuring out, let's see, where's that 70% area? So kind of right there. So we could create our interpolated line, point A to point B. And then, so we have that line, understanding this is creating where our topographic profile would be. So if we were to cut the Earth in half, this would give us the profile or 3D image of the steepness of the slope. So now that we've interpolated a line, so we created a 3D line by interpolating height from the selected surface. So we created that line, we can then use our profile graph option, and it will show us what that area looks like. So we can, this is starting 0, this is distance at the bottom, and this is elevation on the Y axis. Make this a little bit larger. So you can see this is our starting point, where it is 0, and as we get further away, as we cross this valley, we can see elevation increase and decrease down into that valley, and then increase back up to this point around here. So we could add back in some of those values too. But this starts to give you an idea of what this looks like, of how steep this is. So topographic profile important. Maybe if we are trying to put a road in here, this would be, you know, the road that you're drawing. Maybe not the best way to go, because we're going to have to build a bridge. I'm going to guess this is in feet or meters, but a pretty large distance across if we wanted this to be here. If we're drawing a road for some reason from peak to peak. But maybe a cable car makes more sense. That would be, still need to know for that. But maybe not a road in here. So topographic profile, that's what we'll be doing in your lab. So these are just some of the last couple tools, kind of wrapping it all up and seeing what you can do with all of your terrain data that hopefully will help you on your final project.